I'm closing this topic, and we'll take the next topic. It is about digital voltmeter. Now, different digital voltmeter technologies we'll discuss, and they are very interesting. And digital voltmeter is basically not like other digital instruments, which employs the A to D converter, and then once your meter. I'm more concerned about the metering instrument. So it is not the other kind of digital instruments where we are required to convert the analog signal into the digital signal, and then digital numbers are calibrated in terms of the here the DVM digital voltmeters are having its own technology, and we'll discuss today. And it is um, not only one technology, there are the different technologies. So one of them is the most prominent one, is to convert the analog voltage signal into time, and then time is measured. In digital domain, it is very easy to measure time, because we are having clock pulses as an integral part of the digital hardware. So it is always available. So if we, and very accurate clocks are used. So using so in digital domain, it is in hardware, it is very easy to measure the time accurately. So a class of the digital voltmeter, this concept, or this method is used, where the um, analog signal is converted into the time, and time is measured. Then there is a relation between, obviously, voltage and unknown voltage and time. Then with the help of this relation, the output scale is calibrated. This is how so I'm starting with it. Is very interesting. I hope that I'll be able to make you understand, but only thing is that you try to concentrate. It's very simple, very simple. Anyway, these are the details for you, but I'm coming to this diagram. So this diagram is, you can see that it is having two comparators. I think you must be aware of the comparator. जानते हैं आप? ऑपरेशनल एम्पलीफायर का जो सिंपलेस्ट सर्किट है वो कंपैरेटर. तो डू यू नो कंपैरेटर? कोई जानता है कंपैरेटर? हाँ भाई, तो जानते हो तो हाँ बोल दो, नहीं जानते तो बोलो नहीं. हमारी आवाज तो सुन रहे हैं आप लोग?
Yes, sir.
Yes, sir. Sir, we have studied it in the third semester. So
थर्ड में छोड़
little.
के चले आए हैं? थर्ड में ही छोड़ के चले आए? You are required to carry
एक
all your
सेमेस्टर तक
knowledge.
कैरी किया था,
फोर्थ तक कैरी किया था. हाँ भाई, कोई ऐसा है
सॉरी
जिसने
सॉरी
सिक्स
सर,
तक कैरी किया है?
सॉरी सर.
नहीं, यू शुड बी सॉरी टू योरसेल्फ. सिक्स तक कोई ऐसा है जिसने सिक्स तक कैरी किया? मतलब दिस इज द सिंपलेस्ट सर्किट.
सर दो वोल्टेज या करंट को सर कंपेयर करता है और आउटपुट शो करता है.
क्या करता है?
वन इज लार्जर.
क्या करता है?
कंपेयर वोल्टेज या करंट को
कंपेयर करता है.
यस सर.
किस चीज को कंपेयर करता है?
टू वोल्टेज या करंट को.
वोल्टेज या करंट को? अरे तो बड़ी प्रॉब्लम है.
बिटवीन टू वोल्टेज.
एनीवे, इट कंपेयर्स बेसिकली वोल्टेज, वन वोल्टेज विद अनदर वोल्टेज, है ना?
यस सर. बिटवीन टू वोल्टेज और बिटवीन टू करंट.
अब अच्छा मेरी सुन लो, अब छोड़ो तुम. सो in this case, generally we take one reference voltage. One reference. Suppose this is your reference voltage. एक ये reference voltage है. This is the last chance. This is very simple, simplest operational amplifier based circuit. This is your reference voltage. VF. Suppose I'm just taking an example. This is your reference voltage, and another voltage V are, it may be source of, the source of this voltage may be some circuit or something, some sensor or something, whatever. So obviously this is suppose a varying voltage. So this voltage may be, you are comparing this voltage with this voltage. So what will be the possibilities when you are comparing a unknown voltage with a reference voltage? What are the possibilities? या तो ये वोल्टेज इससे ज्यादा होगा या इससे कम होगा, है ना? So when this voltage is more than this voltage, then what will be the output? And when this voltage is less than this voltage, then what will be the output? G. In comparator or in any operational amplifier, along with this we are having bias voltages also. And biasing voltages will be minus VCC. Always your operational amplifier require these supplies, irrespective of its application. So minus VCC and plus VCC. So because the unknown voltage that we want to compare with the reference, so reference voltage is we are applying on the non-inverting terminal, and the unknown voltage we are applying on the inverting terminal. When your unknown voltage is more than reference voltage, then anyway I'm not able to write properly, then output will be minus VCC. Output will be minus VCC. Anyway, this laptop, this I'm not able to, minus VCC. And when your reference voltage is less than, sorry, your unknown voltage is less than reference voltage, means your reference voltage is more than unknown voltage, then output will be plus VCC. So you can see that when you will find in this comparator, when you will find plus VCC, then it is obvious that whatever voltage we have connected to the non-inverting terminal, it is more than the voltage connected to the inverting. And if it is minus VCC, then it is other way around, that whatever voltage that you connected to the minus inverting terminal, it is more than the non-inverting terminal. So this is how your comparator works. Then there are many ways to use it, but in any case, this is, so output is binary. You can say that output is binary. So you can treat this circuit as a single bit analog to digital converter. Wherever in control circuit, in automation circuit, in instrumentation circuit, wherever we require a switching application, then we, instead of going for Means like we want that suppose we are having a temperature sensor, and we want to um, switch on the heater when the temperature is less than certain value, and switch off it when more than. So accordingly we'll have suppose RTD is the sensor, then the voltage will convert this RTD resistance into the voltage, and this voltage is compared with a certain reference, and then accordingly we'll choose the reference, and we'll put it either on the inverting terminal, or it is not universal. You can have this voltage here, and you can have this voltage here. Obviously the corresponding output the will change. So in this case, we want that when the temperature is less, then your output should be high, and so that you can switch on the heater. And when temperature is high, then you should have low output, and then you can switch off the heater like that. So this is a very very good and very simple hardware that suits very well when we are interested in converting certain voltage levels into the switching signal, or into the one bit binary signal. So this you must have studied, and this is the way it works, and this is how it is used. And if you want to convert output right now, your output is basically output is in form of bipolar binary, means minus VCC or plus VCC. Now if you want to that your output should change, so we can say that our output is changing between -1 and +1. And if you want that the output should change between 0 and 1, then one of the VCC should be grounded. Like if I'm minus VCC, I'm grounding instead of putting plus minus VCC certain voltage, we are grounding. So obviously your output will change between 0 and plus VCC, 0 and plus VCC. So it will be purely work as a binary output. So it is clear to all of you. I did not discuss RAM type DVM. I just discussed the comparator circuit, how operational amplifier based comparator work. तो ये आपको पहले भी पढ़ाया गया है as per your confession. So I hope that I'll be able to activate those neurons which were holding this information, and all of you should be um, will be will be agree with my version of the comparator working. Is it fine to all of you? अगर आपका कोई क्वेश्चन है कंपैरेटर के लिए तो आप पूछ सकते हैं। जी भाई, आगे चलें भाई।
Yes, sir. Yes, sir.
जी, with your permission should I proceed?
Yes, sir. Yes, sir.
Acha. Now I'm coming to this RAM type DVM, and in this case you see we are using two comparators. Obviously wherever we are using comparator, then it is used for the switching, and this comparator is called input comparator, because the whatever voltage that we are interested in measuring, unknown voltage, that will be through ranging, proper ranging and attenuation, it is applied to one of the inputs of this comparator. And the another comparator is called ground comparator, because in this case the reference voltage is basically your ground voltage, and we are means here you can see that what exactly this is your RAM generator, because it is a RAM type DVM, so it is a RAM generator. RAM generator, you obviously from the name, it must be producing the ramp signal, ramp voltage signal. So here what is going on, if you look upon the inputs of the comparator, so our unknown input, and obviously the voltage which we will unknown voltage should be DC. So if you are we are talking about the AC voltage measurement using DVM, then this AC voltage should be converted into the corresponding value of DC, and then it is measured. And anyway, it is calibrated in terms of AC as well as far as the digital readout is concerned. So in this case, DC voltage here, the DC voltage is compared with the ramp voltage. Right? One input is the unknown voltage, and another input is your ramp voltage. With this comparator is comparing the ramp voltage with the input voltage, and this comparator is basically comparing the ramp voltage with the voltage, ground potential. So here in this case, your ramp voltage signal is same in both the comparators. One is basically comparing the ramp voltage with the input voltage, and another is comparator is comparing it with the ground potential. So obviously, whenever this voltage or your ramp voltage will become more or less than the input voltage, then you will find the change here. And means um, I will come to that, and that change will be used to basically open this gate. This gate will be open, and then when this ramp voltage is going crossing ground potential, then another pulse will get from the comparator, or change will get from the comparator, and that change will basically close the gate. And whatever is the timing of the opening of the gate, during that time the oscillator pulses, the output of the oscillator, this is a pulse oscillator, will cross it, and it will be counted by the counter. So this is how this setup works. Then how this setup is used for measurement of unknown voltage, that I'll try to explain with the help of this wave diagram. So here, if you look, this is very interesting. I wish that all of you should concentrate and try to understand. And if you feel any difficulty in understanding any of the points, you can ask at that time. So it will be very easy to for me to explain you. So in this case, you see, this is your ramp voltage, and coming from the ramp generator, this ramp, then again another ramp will be generated depending upon how much is the ramp frequency you have. And this is your unknown voltage, this is unknown DC voltage. Now you see, your ramp voltage is ramping down, and here it is crossing. So I'm talking about when your ramp voltage is more than the unknown voltage. So because this comparator is basically comparing the ramp voltage with the unknown voltage. So when suppose this suppose this is your non-inverting terminal, and this is your non-inverting terminal, and this is your here. So when your ramp voltage is more and your input voltage is less, means during this region up to this point, from here to here, up to this point, obviously your input comparator output will be plus VCC, plus VCC. When at this point, after when it crosses this point, then your your ramp voltage is less than the DC voltage, then obviously your output will change from plus VCC to minus VCC. And at this point, this gate is sensitive to, you can say, negative edge, and it will be open, and it will remain open till remain open till your ramp voltage will reach to the ground potential. This is your ground potential. So when will it will hit the ground potential? Then before that, because again I'm telling you, before this point, your ramp voltage was more than the ground potential. So obviously, if again I'm taking it like this, if this is your positive, non-inverting terminal is, and this is inverting terminal. So obviously when ramp voltage is more than the ground potential, then you are having plus VCC here. And the point at which it will cross the ground potential, then it will come to your ground potential become more than the ramp voltage, so obviously it will come to the minus VCC. And at this instant, your stop pulse will stop the gate, and gate will not allow to flow any signal, oscillator signal to the counter. So this is how this. So obviously you see, this is the time, gating time. It is called gating time. This T is gating time to which your gate is open, and your oscillator signal, it is basically clock oscillator. So this clock pulses are reaching to the counter, and if your unknown signal is more, means like here, so obviously your gating time will be more. So this will be your gating time. This will be your gating time. And if it is less, so if it is less, then obviously this will be your gating time, approximately. So when the unknown voltage is more, you'll get more signal, more number of pulses that will be received by the counter. And if your voltage is less, then less number of pulses will be counted. And for every voltage you are having a different counts, and obviously this you must be having a relation between the counts and the voltage, and by this relation we can calibrate our meter in terms of the. So this is how the RAM type DVM works. So if anybody is having any question regarding whatever I have discussed about RAM type DVM, you try to absorb it by the time I'll take your attendance. So this I'm keeping open. If you are having any question, you can ask after I finish the attendance. Now you respond your roll call. Roll number 1.
Present, sir.
You must have gone through this diagram, and then you try to comprehend my explanation of this diagram. So if you are having any query, you can ask, please. And if you are not having any query, then I'll have one query. G. You don't have any query? You all understood what I tried to explain you about the RAM type DVM? G. Should I proceed now?
Yes.
What is the function of sample rate multivibrator? In digital instruments, because it is a discrete kind of technology, so here in this case, whatever signal, analog signal we are trying to measure with the digital setup, then it takes the sample of the signal. The at particular instant it picks the signal, and that signal is basically measured and displayed. Then it is required, always required. In analog signal situation is very simple. आपका voltage है, अगर vary कर रहा है तो spontaneously आपका मीटर का रीडिंग भी वैरी होता रहेगा. लेकिन डिजिटल इंस्ट्रूमेंट में ऐसी सिचुएशन नहीं होती है. आपने एक सैंपल उठा लिया, इफ यू आर नॉट हैविंग एनी अपडेट मैकेनिज्म, तो वही वोल्टेज की वैल्यू चेंज हो गई, लेकिन आपका आउटपुट वही दिखाता रहेगा। तो इसीलिए इसमें सैम्पलिंग करते हैं हम। देयर इज अ मैकेनिज्म वी थ्रू विच योर digital instrument acquires the samples of the signal at regular interval, and it is always, it is means any digital instrument, measuring instrument I'm talking about, if you are talking, then there is a sampling rate also. So this basically, you know, in this case, अब जो भी आउटपुट वोल्टेज है वो अब वो चेंज होता रहेगा, देर इज नो इशू, लेकिन आपकी यहाँ रीडिंग भी चेंज होनी चाहिए, ये आउटपुट पे रीडिंग भी चेंज। इसको ये तब चेंज होगा जब हमारा रैम्प सिग्नल अगेन एंड अगेन कमिंग। तो जो भी फ्रीक्वेंसी है जिससे आपका रैम्प सिग्नल जनरेट हो रहा है, दैट इज बेसिकली सैंपल रेट मल्टी वाइब्रेटर, एंड उसी 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 रेट पे आपका आउटपुट अपडेट होगा। यू कैन सी दैट जब नया नया जो है रैम्प सिग्नल हम जनरेट कर रहे हैं, उसी टाइम हमने काउंटर को रीसेट भी कर दे रहे हैं, है ना। दिस इज योर रीसेट, from here it is coming, it is resetting it. So here in this case, this is one measurement cycle, एक रैम्प सिग्नल आपका कंप्लीट हो गया, एक साइकिल कंप्लीट हो गई। अब उसके बाद यहाँ पे ये फिर दूसरा जनरेट कर देगा आपका जो रैम जनरेटर, और उसकी कितनी फ्रीक्वेंसी होनी चाहिए ये आपका वो मल्टी वाइब्रेटर तय करेगा। अब सपोज करो कि ये वोल्टेज चेंज हो गया, यहाँ पे ये वोल्टेज हो गया, लेकिन आपका मीटर वही दिखाता रहेगा अनलेस अंटिल देन सेकेंड मेजरमेंट साइकिल इज अपडेटेड। और अगर आपका कोई चेंज बहुत छोटा है, सपोज करिए यहाँ हुआ और फिर यहाँ जाके फिर यहाँ हो गया, और आपका सैम्पलिंग रेट उसको, क्योंकि उससे आपका सैम्पलिंग रेट जो है वो उससे कम है, ये जो सिग्नल चेंज हुआ ये फास्ट चेंज हुआ, लेकिन सैम्पलिंग रेट हमारा उससे कम है, तो ये जो फास्ट चेंजिंग कोई वोल्टेज होगा उसको हमारा हमारा जो है मीटर नहीं पढ़ पाएगा, नहीं रिकग्नाइज कर पाएगा। इसीलिए आपको अपने सिग्नल की इंफॉर्मेशन होनी चाहिए कि जो फास्टेस्ट चेंज है वो कितने टाइम का है, उसी हिसाब से आप अपने ये मल्टी वाइब्रेटर सैम्पलिंग रेट जो है उसको चूज करें। ये बात आपकी समझ में आई कि नहीं आई? भाई हाँ नहीं तो बोलो, तुम लोग कुछ बोलते ही नहीं हो, सोते रहते हो।
एक बार और बताएं।
So this is how your RAM type RAM type DVM works, and these whatever I spoke, this is written here. When you refer to my slide, then through these explanation you can recall all the explanation. Now the another one is dual slope type DVM. This dual slope type DVM is again the basic principle remains same. In RAM type also, the voltage is converted into the time, and then time is measured. You can see this, we are basically measuring the time. Similarly, here also the voltage signal is converted into the time signal, and time is measured. Here in this case, the signal and the technology is different, but the concept remains same. It employs basically your dual slope type DVM employs integrator. Heart of it is integrator. So you can see that this is an integrator circuit. Can you tell me if I'm feeding an integrator circuit like this, analog integrator circuit, if we are feeding it with the DC input, then what will be the output? अगर किसी इंटीग्रेटर में हमने एक डीसी इनपुट दिया, डीसी वोल्टेज इनपुट दिया, तो आउटपुट क्या होगा? ये तो बड़ी गलत बात है भाई। जो आपका ये सर्किट है वो यही तो करता है कि Vx को विद रेस्पेक्ट टू टाइम इंटीग्रेट करता है, और Vx जो है हमारा वो बेसिकली डीसी वोल्टेज है, कुछ टाइम पीरियड 0 to t इंटीग्रेट कर रहे हैं। तो आउटपुट क्या होगा? ये वी आउट है आपका। ये सर्किट यही फंक्शन कर रहा है, इसीलिए इसको हम इंटीग्रेटर सर्किट कहते हैं। इनपुट वोल्टेज दिया, उसको हम टाइम के साथ इंटीग्रेट करते हैं विद रेस्पेक्ट टू टाइम। यही तो होता है ये इंटीग्रेटर सर्किट। तो आउटपुट कैसा मिलेगा आपको?
स्ट्रेट लाइन।
जी, कैसा आउटपुट होगा?
सर
राइट से
रैम।
हैं?
सर रैंप टाइप होगा।
क्या होगा?
रैंप टाइप।
रैंप होगा, है ना। तो भाई आप इसको, क्योंकि ये कांस्टेंट वोल्टेज है, ये वोल्टेज कांस्टेंट है, तो ये इंटीग्रेट टाइम के साथ चेंज नहीं हो, डीसी वोल्टेज है, टाइम के साथ नहीं चेंज हो रहा है, तो ये बाहर चला जाएगा इंटीग्रेटर के, इंटीग्रेशन के कांस्टेंट है ये। तो ये x हो गया, और 0 t, तो ये t हो गया। तो ये क्या हो गया? y इज इक्वल टू एम एक्स। ये y हो गया, ये m हो गया, ये x हो गया। तो ये क्या होगा? अगर आप इस वोल्टेज को विद रेस्पेक्ट टू टाइम प्लॉट करेंगे तो y इज इक्वल टू एम एक्स वाला, है ना। तो ये ओरिजिन से ये रैंप हो गया। और अगर आपका ये वोल्टेज पॉजिटिव है, जो इनपुट वोल्टेज दे रहे हैं डीसी है, पॉजिटिव भी हो सकता है, निगेटिव भी हो सकता है। तो सपोज ये वोल्टेज पॉजिटिव है या ये वोल्टेज निगेटिव है। अगर ये पॉजिटिव है तो आपका ऐसे जाएगा, सपोज ये पॉजिटिव है तो ऐसे चला गया। और अगर ये फिर दूसरा रेफरेंस वोल्टेज है, ये निगेटिव है, तो ये रैम्प डाउन हो जाएगा, लेकिन रहेगा रैम्प ही, है ना। इस केस में अप हुआ और इस केस में डाउन, या अदर वे अराउंड। अगर वो पहले वाला निगेटिव है तो पहले ये इधर जाएगा, फिर बाद में अगर आप पोलैरिटी चेंज करते हैं तो। ये बात सबकी समझ में आ गई भाई? अभी हमने डीवीएम नहीं डिस्कस किया, अभी हमने सिर्फ इंटीग्रेटर डिस्कस किया है। ये बात सबकी समझ में आ गई?
यस सर।
जी,
यस सर।
कुछ बोलते ही नहीं है तुम लोग भाई। अगर नहीं समझ में आएगी तो बता दीजिए, हम आपको समझा देंगे। आई एम सिटिंग हियर फॉर दैट पर्पज ओनली।
आ गई।
आ गई, चलिए, बड़ी मेहरबानी। नाउ I'm coming to the dual slope type DVM. What is the method? This dual slope type DVM is having integrator and a reference voltage source inside the voltmeter itself. And then we apply the DC voltage which is unknown and we want to measure Vx. Then obviously the integrator output will be this one, है ना? This one, where R is this and C is this, and this is a ramp voltage. Now what we do, we connect the unknown voltage for a constant period of time, that is T1. T1, this is the T1. So obviously this will be the output voltage. When the now means what we do, we apply this voltage, this voltage to here for a unknown voltage to the voltmeter for a constant period of time, and that period of time is t1, and that is known, that is known. After this, the input is your voltmeter is disconnected internally from the input, and it is connected to the reference voltage. And this is the mechanism which is present in the voltmeter itself. Whatever is the polarity of the input voltage, the reference voltage polarity will be opposite to that. And now your your reference, your integrator will be connected to the reference voltage till your output becomes zero. Means the situation is like this. Suppose your input voltage is positive, so we will have a ramp down voltage when the unknown voltage is connected. And then obviously when this is positive, then reference voltage will be negative, so your, and it will remain connected to it till your voltage reaches to zero. If situation is other way around, if your input signal is negative, then your output will be ramp up, and then obviously your reference voltage will be positive. Then in that case it will be connected to that time, by which, by that time it is coming back to the zero value. So this is how your dual slope. And why it is dual slope, you see, slope is basically decided by the unknown voltage and reference voltage. So if unknown voltage is high, then your slope will be high. And the same time you will reach higher voltage, more voltage, more higher voltage you will reach, and you will take more time to reach zero value, because ramp down your ramp down slope fixed. V reference is fixed, it is not changing, although this is changing. So the more voltage, so it will take in the same time t1, it will go to ramp up to or ramp down to the more voltage. So, and your ramping down is slope is same. So when the voltage is more, then it will take more time to reach to the zero value, like this. So this way, more voltage is connected. I'm sorry, more voltage is connected, it will take more time, and this way your voltage signal is converted into the time signal, and then this time is counted, measured, and then calibrated again in terms of the unknown voltage. So here I'm stopping to my today's discussion, and we will tomorrow I'll start my lecture with the dual slope type DVM. This is fine to all of you? Okay, thank you.